Hello, am I audible to you?
Yes, sir. You are audible, sir.
So you want to give up for a strength of material, na?
Yes, sir. Actually, I'm going for ONGC interview, sir. So, strength of material is better, no?
Vijender, just define yourself. Okay.
Myself.
Yeah. Just define
Sir,
yourself.
I'm Midun Das KM. I'm from Thrissur, Kerala. I did my 10th from Kendra Vidyalaya, number 2 Nail Base Kochi. Then 12th from Irnyalakuda Bhavans. Then I did my B.Tech in Mechanical Engineering from Cochin University of Science and Technology. Then after that, I also have completed 1 year GME course in marine engineering. Then I worked in DRDO for about 19 months as junior research fellow. And then I gave the gate and resigned in November 2021 and prepared for gates.
Okay. So you are working at DRDO as a JRF. Okay.
Yes,
Am
sir.
I right?
Yes, sir.
Okay. Just tell me what are you doing in a JRF as a JRF? Which
Sir,
work?
there I used to uh, I used to do the designing and analysis of marine structures. Basically, I used to find out the where we used to give the boundary condition in the ANSYS workbench, and we used to find out where the stress is coming maximum, and we used to rectify it if it was not in the safe limits. We used to modify the structure.
Okay. Good opportunity to work as a JRF, and you can pursue your career as a JRF, SRF, and also the PhD. Then why would you just switch the job here?
Sir, that was not permanent, sir, and the pay scale is also low, and it was not a permanent job, sir. I wanted a guaranteeing job, so ONGC was a better option, sir.
So just tell me, if you want to just design a shaft, how can you design the shaft? Which parameter you are just considering, and what are the various factor you are just focus into that? है ना? Just tell me the answer.
Sir, for designing a shaft, we'll have to first know the torque, power it should be transmitting. From that power, we can determine the torque it is transmitting. So, if torque and power are given, we can determine the diameter using that formula T by J equal to J tau by R. From that, we can if we can if the stress maximum stress limit is also given, we can decide we can choose the material also, and like that we can choose.
There is no need to select the material, and there is no need to take the any factor of safety. And
Yes, yes, sir, yes, sir. Factor of safety is all. If factor of safety, we should consider factor of safety as well, and we should try to minimize the material. Like if a hollow shaft, if we have if we have space constraint, then we should go for solid shaft. If otherwise, if space constraint is not there, hollow shaft will be better, because if we use hollow shaft, we can save material as well as, but we can transmit the same power with that hollow shaft. Likewise, we can see, sir.
okay, so you are belongs to the mechanical, na?
Yes, sir.
If you want to just design a crankshaft, how can you design?
Crankshaft.
Yeah.
Sir, we first we used to we need to find out the engine indicate piston effort by the bursting of this gasoline or diesel. The amount of energy released will be transferred into piston effort. That piston effort will exert a torque on the crankshaft. So that according to that torque and according to the load that the crankshaft is taking, if it is of a automobile, the load will be coming as of the weight of the automobile and passengers. According to that, we can decide the shaft, and also according to the type of bearing we are using. Uh, for like marine engines, crankshaft and all, we'll have to use journal bearing and all. But for automobile, we can use ball bearing, roller bearing and also.
Okay.
Like
Just tell me, what is the use of a factor of safety?
the factor of safety, uh, uh, we are giving a margin, sir. if a material fails at 100 megapascal, if we design it for 100 megapascal, then it is at a riskier this situation, sir. If we instead, if we design it for failing at 150 or 200 megapascal, then in real time experience, even if the load crosses the 100 megapascal margin, then also it will be in safer conditions, sir. To make
Why we need a take a safer condition? Is there any necessity for that?
sir,
When we are know ki if a material is going to fail on the 100 megapascal, then we directly use the material which is having the limited of 100 megapascal.
sir, real time situation will not be as we calculated in analytical or graphical methods, sir. It will be different real time, because a material, we have so many assumptions, like a material, while calculating we have so many assumptions like material should be homogeneous, isotropic, and prismatic, and all those assumptions are not valid in real time situations. In real time situations, the material may be different, maybe anisotropic in some directions, maybe not non-homogeneous, maybe there are some cracks. So to accommodate for that, we give factor of safety. So like that.
Okay. What do you mean by notch sensitivity?
So notch sensitivity, sir, equation only. Sir, actually, if a notch is being created, the stress lines, it will be the stress lines will converge near the notch. Uh, Sir, I am not that sure about it. I only remember the equation kf equal to q, kf minus 1 equal to q into kt minus 1, sir. In that,
Okay.
q is notch factor, that much I remember, sir.
Okay. Just tell me about Soderbergh-Goodman line.
Sir, it is Soderbergh and Goodman are designing condition for varying load situation. When load is in transient, like it is.
Just tell me in which condition we are using a Soderbergh line, in which condition we are using a Goodman line, in which condition we are using the Gerber line, and what are the equation of that?
Sir, Goodman is sigma sigma median divided by let me think, sir. Okay, so, the sigma mean divided by SUT plus sigma mean divided by sigma amplitude. The sigma amplitude divided by S and endurance stress equal to 1 is Goodman. In Soderbergh, instead of sigma ultimate strength, it will come yield strength. Sigma mean divided by SYT plus sigma A divided by S and sigma endurance equal to 1 is Soderbergh. And Gerber is sir, equation only I remember. Sigma mean by sir, that also I'm not sure, sir. Soderbergh is a bit more safer conditions, sir. Goodman is
For which material we are just considering the Soderbergh, and for which material we are taking the Goodman?
Soderbergh will be for ductile material. Goodman will be for brittle material.
Okay. So can you just tell me what do you mean by Sommerfeld number?
Sommerfeld number. So that is for bearings. We assign a number. With that number,
What is the formula of that?
Zn by let me think, sir. Zn by P. Where Z is viscosity, N is RPM per second, rotation per second, and P is the pressure acting on the that pressure is taken by the pressure acting on projected area of the bearing. Zn by P. Zn by P into D by C. D by C the whole square is also there, sir. That is D is the diameter and C is the diametrical clearance, the whole square.
Okay. So just tell me what do you mean by P? here represent? What is the formula for P here?
Pressure is the total load divided by if bearings projected area, sir. Diameter into length.
Okay. So I will just give you the feedback. Overall, you are really good, and your way of speaking and giving the answer is also good. There is no issue, है ना? You have a
Okay,
good confidence, but I think little bit some confusion you have in a subject. So
okay,
एक बार just revise once a subject, so you will be
okay, sir.
confident and give the answer in a very well manner. Okay.
Okay, sir. Thank
Okay.
you. Sir.
Thank you so
Thank you.
much.
Thank you, sir.